Hi everyone, and welcome to our video on trigonometry. All right, so I'm going to talk about a few things really quickly, and then I'll get into the things that are probably most important. So some obvious things: circles. They have a radius. I think we all know what that is. They have a diameter. The radius is half of a diameter, or diameter is 2 times r. Circumference is 2 pi r, and area is pi r squared. I don't think I should talk too much about that because I want to get into more useful things or things that we'll use more often, which is triangles, especially right triangles. Okay, one thing that might be useful to talk about just for a few seconds here is complementary angles and supplementary angles. So if we have a situation where we have a 90-degree angle, we can divide that into, maybe there's two angles, and we just have to know that, A plus B, the angles of A plus B is going to be 90 degrees. Now for supplementary angles, we can see here, like we have A and B. Again, depending on what the angles are, let's say B is, 80 degrees, and then maybe A over here is 100 degrees. Obviously, right, they're just going to add it to 180 degrees. Okay, so that's pretty straightforward, but we might use that here and there. All right, the things that we'll probably use the most are triangles, especially right triangles. So one thing to kind of keep in mind is the Pythagorean theorem, right? A squared plus B squared equals C squared, as well as this acronym of SOHCAHTOA. So really quickly to kind of talk about some of those things. So we might have a situation where we have some kind of line like this, and then just to kind of review triangles here, right? We have the adjacent side, and maybe we'll call this A, and then this is the opposite side. Maybe we'll call this B, and then we have the hypotenuse, and we'll call this C, right? So when we talk about A squared plus B squared equals C squared, those are the three sides that we're talking about here. All right. Obviously, this is a right triangle, so it's 90 degrees, and then we might want to know, like, what is this angle here? Typically, we use this symbol theta for an angle that we are missing. And then really quickly to kind of talk about SOHCAHTOA, I mean, you probably already know this, but just a quick review. So when we talk about SO, right, that's sine of our angle is equal to opposite over hypotenuse. And then cosine, or the ca part, is cosine theta is equal to the adjacent over the hypotenuse. And then TOA, which is tangent of theta, is equal to the opposite over adjacent. Okay, and so that would be pretty useful when we're dealing with some situations. And maybe we can do a few examples here. So let me maybe erase some things here. Maybe I'll just kind of get rid of this, and we will do an example. All right, so let's say we have an example here. Let's say we have a triangle. I don't know. And then let's say we know that this is 12. I didn't draw this to scale, but let's say this is this angle here. Let's say this is 30 degrees, right? And let's say we want to figure out the x part and the y part. This is actually very typical in physics. We might know that we have like some kind of line that's maybe going this way at an angle. And then, well, it's kind of tricky to deal with something that's at an angle, but what we can do is we can break it down to the x and y components. So what we would do here is we'd say, okay, well, I know that cosine of theta is, again, that's equal to adjacent over hypotenuse. Well, I know that for this case, we have cosine of 30 is going to be equal to, let's just call it x over 12. And then to rearrange this, I could do 12 cosine 30 is equal to x. All right. And then from there, it's a pretty simple mathematical operation. All right. We could do the same thing for the y component. So we could say that for sine of theta, that would be opposite over hypotenuse. So if we're going to plug in our values here, we'd go sine of 30 is equal to y over 12. And then same idea. We just move the 12 over, so we have 12 sine 30 is equal to y. Okay, and again, that's a pretty simple mathematical operation. You'll see that whatever your x and y values are, they're going to align with this. So you could even check your work and say, okay, well, x squared plus y squared is going to be equal to 12 squared. Okay, and then maybe I'll do one more quick example here. So let me erase this, and then we'll do an example where, well, what if you're not given the angle? What if you're given some of the numbers here, but you're not given an angle? So let me kind of erase this, and we'll do a different situation here. Okay, so let's say we're given a different situation. Let's say we have some kind of triangle here. Try to draw this well. I don't know. I'll leave it a little bit not to scale, but that's okay. Let's say this is 3, this is 4. We have an angle here. But let's say we don't know what that angle is, right? So what we can do is we can do our tangent operation. We could say, well, tangent of the angle is going to be equal to the opposite over the adjacent. So it's going to be 4 over 3. So in this situation, what you want to do is you want to do inverse tangent. So we go tangent, inverse. We'll go 4/3 equals theta. All right. And so you could just enter this into your calculator. You could do theta is equal to 53 degrees. Okay. All right, and that's going to show up a lot in terms of some of the problems that we do. We might have some kind of force or some kind of velocity or movement that is not quite on a horizontal axis or a vertical axis. Maybe it's at some angle. We might need to find that angle, or we might need to break it down into the x and y components, which we'll get into during the first unit. Okay, I think I'll stop there. And then our next topic will be about algebra.